Okay, let's do question 3 of part 2. And this was an abstract groups question. Given a group G, let ABC be elements of G. Find and prove a formula that gives ABC inverse in terms of A inverse, B inverse, and C inverse. In other words, write down an equation in the form ABC inverse equals expression containing A inverse, B inverse, C inverse, and prove your expression does indeed satisfy the condition for the inverse of ABC. All right, now, if you remember in the chapter, you had an expression that AB inverse equals B inverse, A inverse. That kind of tells you that when you take the inverse of a product, you have to reverse the order of the inverses. If you've had linear algebra, you've seen this also. So it makes sense that if you have 2 and you take the inverse, you reverse the order. If you have 3, you should still reverse the order. So I can prove this 2 ways. First of all, I can do from scratch. And this is using the definition of inverse. I'm going to prove that C inverse, B inverse, A inverse times ABC is identity. And ABC times C inverse, B inverse, A inverse is the identity. And that means that C inverse, B inverse, A inverse is the inverse of ABC by definition. So let's go ahead and prove this. C inverse, B inverse, A inverse times ABC. If you reassociate and put the A inverse A together, that gives you the identity by the inverse property because A inverse A cancels out. Yet identity goes away because of the identity property. Then I can reassociate and bring the B inverse B together. That becomes the identity by the inverse property. By the identity property, that goes away. And then by the inverse property, I get the identity. So I've shown that C inverse, B inverse, A inverse times ABC is the identity. To complete the proof that C inverse, B inverse, A inverse is the inverse of ABC, I need to show the other way also. And I don't show it because it's really identical proof. Just shuffle some things around. So by the definition of inverse, we get that ABC inverse equals B inverse, C inverse, B inverse, A inverse. Now, there's a shortcut proof because we've already proven this result in the chapter. AB inverse equals B inverse, A inverse. So instead of doing 3 applications of the inverse property, we only need 2. The way that works is as follows. Here I have C inverse, B inverse, A inverse times ABC is equal to, so here I reassociate this way, and then because B inverse, A inverse is the inverse of AB, I can cancel that out and make that identity. Then I use the identity property to make the identity go away, and then I use the inverse property. And use the same proof to show the other way, ABC times C inverse, B inverse, A inverse is the identity. So that gives me the complete proof. So I get it both ways. All right, that's it.